Today we are going to discuss Taylor and Maclaurin series. Here you can express a function f of x using infinite terms of this Taylor series, as you can see here. And as a special case of Taylor series, we have a Maclaurin series, which is considered as a equals 0. As you can see here in Taylor, if you consider that this a equals 0, so it will be Maclaurin series. For example, if you wanted to express this function y equal cosine x using x equals pi over 2, and we wanted to express this function as three non-zero terms, so we have to find here y equal cosine x. It means that the function f of x equal cosine x, we can find some few derivatives, f prime, f double prime, and so on, and we have to substitute x equals pi over 2 in each one. So f of x equal cosine x, therefore f of pi over 2 equals 0. F prime, which means derivative of cosine x, which is negative sine x, therefore f prime pi over 2, you can substitute here x equal pi over 2, and the result is negative 1. F double prime, derivative of negative cosine, negative sine is negative cosine, you can find f double prime of pi over 2 equals 0, and so on. And after that you can substitute in Taylor series here in this rule. Therefore f of x equals, after substitution in the rule, you can see that f of x equals the summation of these terms, and you can simplify, so you can get f of x equals these terms. Another example, express again y equal cosine x, but using Maclaurin series. Maclaurin series, so we have to consider a equals 0. This is f of x, which is cosine x. Find some few derivatives, f prime, f double prime, and so on, and you have to substitute x equals 0 in each one. And after that, use this rule of Maclaurin series and substitute from above here, so you can express f of x using these terms. Finally, we have f of x equals 1 minus x squared over factorial 2 plus x power 4 over factorial 4, and so on. Another example, express y equals e to the power x using Maclaurin series. So our function is e power x. Find some few derivatives for e power x and substitute x equals 0, because here we are working with Maclaurin series, so we have to substitute x equals 0 in each one. And after that you can substitute in the function in this rule, and finally we have e power x is 1 plus x squared over factorial 2 plus x power 3 over factorial 3, and so on. If we wanted to find Maclaurin series of e to the power negative x and e to the power x squared, we got the Maclaurin series of e to the power x, as you can see here, and the steps have been discussed in the previous slide. So you can find e to the power negative x. This is e power x, and if you wanted to find e to the power negative x, therefore you can remove each x here and substitute x equals negative x, because here you have e to the power x. If you wanted to express e to the power negative x using Maclaurin series, so you can substitute each x here as negative x. So therefore e to the power negative x equals 1 minus x plus x squared over 2 minus x power 3 over factorial 3, and so on. And now what about e to the power x squared? Here we have e to the power x. So if you wanted to find e to the power x squared, you have to replace each x here by x squared. So this is your final answer, and this is the Maclaurin series of e to the power x squared.